Is water slippery? Yes, if there's water on the floor, you can slip. So same idea here, we can use water as a lubricant inside the body as well. So it helps to reduce the friction between those two surfaces. And up in lab, we talked about a serous membrane in the heart with the glove. When we do the glove thing, and the two surfaces, the visceral and the parietal layer. We said in between there's like a little bit of a watery fluid to keep it from rubbing together, so it helps to reduce the friction between those two surfaces. So we have that as a serous membrane. We have mucous membranes. So again, just water is great to reduce the friction between those two surfaces. It's a lubricant for us. Great lubricant. Easy enough. Perfect. Okay, so we're good with water? Like we're done with water. Okay. So we know how much water we should drink. Hey, is like water good for your brain too, by the way?
Yes.
They actually say it stimulates your brain. Yeah, so now like even like little kindergartners who have them bring water to class, it does help you with your memory and things of that nature as well. So you gotta make sure you drink plenty of water. How do you never feel like a little dehydrated when you go like to the bathroom? What color is your urine?
Dark yellow.
Yeah, dark yellow, right? Maybe there. So you want it to like straw color instead of you're a little more hydrated. You can also do your skin turgor. So you guys like what skin turgor is? On your hand, you like pinch your little skin on top of your hand, sort of thing, and then you let it go. It should snap back like immediately. If it like hangs up there for like a few seconds, then you're like dehydrated. So you can check like old people like real quick, just like check them. If it snaps back, they're good. If not, they're a little dehydrated. So I'll do a little check for you. So yeah, drink plenty of water. All right, so that was my water thing. Now we're going to do acid and bases. Okay, acids and bases. And here it says for me, here's my definition. An acid will dissolve in water and it's going to release hydrogen ions. A base will dissolve in water and release hydroxide ions. And we'll talk about what a salt is too, right? So a salt will dissolve in water and release something other than hydrogen or hydroxide. So we'll take a look at my two examples. I gave you earlier, for my acid, I said I had, what? HCl, hydrochloric acid, something. For my base, I use sodium hydroxide. And then for my salt, I use sodium chloride. Do there. All right, so this is my acid. This is my base. And this is my salt over here. Okay. What we're saying is I can take my little beaker of water, for all three of them, I guess, right? We just fill all three beakers here. And we'll go ahead and drop this in some water. So when I drop this into water, my hydrochloric acid, I end up with so it cuts it right in half. It ends up looking over here. I have a hydrogen ion. It's positive, so is it an anion or a cat?
Cation.
Sorry, or a cat.
Cat.
Let's say cat.
Yeah. T for cat, T for plus. Did I gain or lose an electron?
Lost.
Lost. Good job. All right, then I have chlorine on the other side. It's negative. So what's going to happen to me? I gained or lost?
Gained.
Gained. Right. So this guy like donates something. Okay, so anyways, when I dissolve it in water, I get hydrogen ions. And let's make this thing a acid. How about this one? We drop this in. I end up with like sodium on this side, your plus, and my OH negative on the other side. That OH negative, that's a hydroxide ion. So when that dissolves in water, I get a hydroxide ion over here. And my third one, when I drop this in water, I get sodium on one side, and I get chlorine on the other one. So I get my two atoms again, but they're not hydrogen, or they're not hydroxide, therefore it's considered to be a salt. So it has to dissolve in water and release other ions other than hydrogen or hydroxide. Pretty good? Make sense? Okay, so if I get hydrogen when I dissolve it in water, it's an acid. If I get hydroxide ions, it's a base. If I get something other than those two, it has to be a salt. That's all we're going to say about it. Just keep it really simple. Okay. I have a picture to show you too. Give you the like mine. So here, actually I used something different. I used potassium hydroxide, so that's over there. So anyways, hydrochloric acid, my potassium hydroxide, and my potassium chloride. So sodium chloride for that one. So anyway, they just dissolve, right? Break apart. So my acid, my base, and my salt. Perfect. So are like certain foods more acidic, like when you eat them?
Yes.
Yeah, they have more of an acid to it, like tomatoes, citrus fruits, coffee, things like that, right? And the other things are like more basic or more alkaline, like vegetables, right? They're more alkaline. What about like proteins, as far as like animal proteins? Are they more acidic or more alkaline, do you think?
More acidic?
More acidic, yeah, yeah. I remember that whole thing, we talked about pH a little bit the other day. You probably didn't remember that, but we're talking about the range for like homeostasis. We're talking about like blood pressure, blood glucose levels, and blood pH a little here. So I gave you a range for your pH. We said it was 7.35 to 7.45. Yeah, pretty small window there, right? Like only 1/10 difference between the two. So your blood pH is really, really, really important because any sign outside of that creates problems. So if you go this way and it's less than this, right? It's more acidic. If you go the other way, you're more alkaline. Now the foods you eat can actually change this a little bit for your body. So your body can be a little bit more acidic or a little bit more alkaline. So if you eat a lot of animal products, like meat and steak and chicken or whatever, right? So you get a little bit more acidic with your animal stuff over here, like animal meats, whatever. And then if you eat more, I don't know, healthy over here, all your vegetables and things like that on the side, you're a little bit more alkaline. So where are they finding that we have an issue with like more acidity in the body? This goes with cancer, right, over here? So it sort of makes sense because people that have a very high animal fat diet, meat products, whatever here, they have a high risk of cancer. How do you get rid of cancer? Or how do you like combat cancer? By eating more vegetables, right? So you're going to drive the alkalinity this way to here. So you got to eat your veggies to like offset the pH of the body. It's like dying out here. All right, so anyways, we got some cool stuff there. So anyways, we're going to talk about this acid-base balance through here. Now we talk about pH, and you might know it comes in a range, and it goes anywhere from 0 to 14. You guys know that? How much if you know about pH? But yeah, it's like an exponent thing or whatever, so they go from 0 to 14. What's right in the center then? 7. Okay, so here's the deal. Anything less than 7 is an acid. Yeah. Anything greater than 7 is a base. So over here. Okay. Here's the other thing I want you to know. The more acidic you are, the more hydrogen ions that are released. So you have like weak acids and strong acids. So you have like stomach acid versus battery acid versus tomato juice versus lemon juice, whatever. They're all acidic, but some of them are more acidic, right? More caustic, I guess you could say through there. Stronger acids, things like that. On the other side, you have more hydroxide ions. So they can be just as bad too, right? Things like bleach, that's pretty nasty stuff. Lye, things like that. So they can hurt you as well. So not just being too acidic, but being too alkaline as well. So here's what you have to do. It says our body works best when acids and bases are balanced, which sort of makes sense because you don't want the extremes because that can really hurt you. So you want to be able to balance them. So AEP2, we're going to talk about balance this whole thing. And it says that acidity and to be more basic and more alkaline, we can measure that using a pH scale, which goes from 0 to 14. And how 7 is neutral, 14 is very basic, and 7 is very acidic. So you probably want to know these numbers, and you probably want to know which one's an acid and which one is a base. And you also probably want to know that you have more hydroxide over here and more hydrogen over here. Sound pretty good? Okay, so you probably already know that, I'm not really sure, but maybe you do. 7 is neutral, right? 14 is basic or alkaline, and 0 is acidic. Okay, let me show you some examples too. So we give like a whole list of things that are out there that you can pick from. And you can see your stomach acid has a pH of about 1. That's some pretty nasty stuff, right? That eats just about anything out there. Coca-Cola, a 3. Yeah. Do you ever feel like little experiment like in middle school. You take a jar or like a little can of Coca-Cola and you put a nail in it. And like after 5 days, what happens to the nail? It disappears, right. So stomach acid is worse than Coca-Cola. I mean, think about putting a nail into some Coke. It eats it away with like what, 5 or 7 days or something like that. So your stomach acid is like even way worse than that. So some pretty nasty stuff. So think about like a lot of people get ulcers and all sorts of like, right, reflux, all that crazy stuff. Hey, lemon juice, 2. That's like even worse than Coca-Cola, right? So nasty stuff. Tomatoes, a 4. Black coffee, 5. Urine, 6. You guys drink urine? You drink urine, that's okay, I guess, right? Human saliva, 7, so it's pretty neutral inside your mouth. Check out the human blood and seawater. It's pretty darn close to about the same thing. So human blood is here, right? 7.35. They show it there, right between the 2. And seawater. So seawater is salt water. So think about pH and seawater and human blood. What's the correlation between the two, do you think? Salt water, blood. What do you start an IV with somebody? It's salt water. Yeah, so if you stick an IV in somebody's arm, you're putting in salt water. So salt water has pretty close to the same pH here, right? It's a 10% normal saline solution. That's what you stick in somebody's arm, right? IV fluid, it replaces blood, pretty much, right? So it pumps you up a little bit there. So you have like those stuff, baking soda, 9, milk of magnesia. You take that when you have what? Upset stomach, because your stomach acid is at a 1. You take that at a 10, it'll buffer it and make the stomach acid less, which helps with your indigestion and things like that. Ammonia, pretty nasty stuff there. Oven cleaner, 13, that's nasty stuff too. And then drain opener down there, that's like really caustic stuff. So if you drink drain opener, what happens? You're gonna die, right? Yeah, don't drink drain opener or anything like that. So, nasty stuff. They actually make like drugs from it, don't they? Drain opener? Do they make ecstasy from that? In your bathtub?
They make
Crystal meth?
That was meth, yeah.
One of those two. Yeah. Go online and like Google that.
So not only
Drain opener, go to neighbor's house. Right, yeah, so drain opener, all nasty stuff, only 50 there. Okay. Yeah, Drano, right? Yeah, same thing, like if you're more visual, right? Baking soda, Clorox, lye. That's like really nasty stuff down there. Oven cleaner. Cool. Battery acid.
Close.
I don't think myself stole this.
Okay, so we sort of mentioned earlier how the acids and the bases need to be buffered, which means we want them more neutral for us. And there are things inside the body that help out with all that, because if you're just drinking a lot of like lemon juice and tomato juice and Coca-Cola, your body has to do something to like offset all that very acidic stuff, right? So your body will convert strong acids into weaker ones, or strong bases into weaker ones by this little carbonic acid bicarbonate buffering system. What do you think about that? That's AMP2, okay? So through that AMP2, the carbonic acid bicarbonate buffering system. So they talk about respiration, they talk about kidney function, or whatever. It helps like convert all that stuff inside your body. So just know it's known as a buffer. Okay, it's going to buffer it through there. So it's like Tums will buffer your stomach, or Rolaids, right? It offsets that. Like what is in like Rolaids anyways?
Calcium,
No idea?
calcium,
Calcium and
sodium bicarbonate.
bicarbonate, right? Like sodium bicarbonate, same thing, okay, so just go with that. Alrighty, so that's all my inorganic stuff. Water, acids, bases, salts.